All right, guys, so I'm just going to quickly review the anatomy of the blood vessel since it's been a while since we've gone over this. So this is just general. I'll do a color. Actually, I'll do a color you can see. Okay, so the tunica intima is made of the endothelium. Okay, so the endothelium is a simple squamous epithelial tissue. So that's going to be right here. The simple squamous epithelial tissue is really important for creating a smooth surface for red blood cells. Okay, you want red blood cells to have a smooth surface so that they don't break, causing a blood clot, which is a big problem. So we have our endothelium. Under that, we have the subendothelium of areolar connective tissue. Then we have our tunica media, made of smooth muscle for vasoconstriction. So we talked about that's how you can close off blood vessels and control where your blood goes. So you can dilate some blood vessels, constrict others. And then outside of that, we have the tunica adventitia, which is dense, irregular connective tissue that loosens as you move out. And that's going to be the outermost layer of the blood vessel. So it makes it strong, it physically attaches it to other tissues, it provides support and protection. So looking at those layers, we looked at arteries first. Then we looked at capillaries. Now today we're going to look at veins. So if you remember last class, we ended, by talking about the 5 major differences between arteries and veins. First was that veins had a larger a larger lumen. So veins are larger than their accompanying arteries. Okay, so veins, we have 2 types. Venules and veins. So again, the first difference is that their lumens are larger. Okay, so these lumens would be larger than the accompanying arteries. Second difference was that the walls were thinner. So in venules, you just have an endothelium. Sometimes you'll have a subendothelium, but that's it. Veins have all the layers, but they're all really thin. So we have our subendothelium, tunica media, tunica adventitia. So you have all 3 layers, but they're very thin. The third difference was that the blood pressure in veins was lower than that in arteries. Okay, the blood's moving slower, so it's not as, the pressure isn't as high. Third, veins do not have vasoconstriction. So you can see they do have a tunica media, but it's not thick enough to actually constrict the vessels. Because of this, veins aren't able to move blood through them, right? They can't constrict to move blood through the lumens. So the last 2 differences is that veins had skeletal muscle pumps and valves. So here we have our vein and longitudinal section. First thing it has is skeletal muscle pumps. So you have skeletal muscles on either side of the vein. And these muscle pumps will squeeze to force blood through. Okay, imagine the veins in your leg. You have to get blood from your pinky toe all the way back to your heart, but you don't have any vasoconstriction. The way you're going to do that is by contracting and squeezing the muscles on either side of the vein. So let's imagine walking. So you're taking steps, your calf muscle is squeezing, and it's forcing blood up. But eventually your muscles will relax again. Every time you take a step, your calf muscle squeezes, relaxes, squeezes, relaxes. Well, as it relaxes, the blood is going to fall back down due to gravity. So the muscle squeezes, relaxes, squeezes, relaxes. Well, that's not really helping. You can't squeeze your muscle long enough to get the blood all the way up to the heart. So the second thing that veins have that arteries do not are valves. So what happens is the skeletal muscle forces blood up. Then when it relaxes, the blood will fall back down and get trapped by the valve. So blood hasn't made it all the way up, but it didn't fall back down due to gravity. Then the skeletal muscle pumps again and then relaxes. And that will just keep happening. So the blood will keep moving up the valves until it gets all the way to the heart. Okay, so those are the last two differences between veins and arteries. Veins have skeletal muscle pumps and valves. Arteries do not. Here's a picture of a venule. So you can see the endothelium, so really smooth layer. This one doesn't look like it has a subendothelium. Maybe it's very small. Maybe it's a little subendothelium right there. Okay, but you can see how small the vessel is. It's barely big enough for multiple erythrocytes to get through. Remember that capillaries were so small that only one erythrocyte can go through, so they go through in single file line. Venules are not much larger than that. Here we have the same slide we looked at in lab. So you guys can see the lumen of the vein is bigger than the lumen of the artery. That's one of the two differences. And the walls are thinner. Okay, so the vein has the tunica intima, tunica media, and tunica adventitia, but it is much thinner than that of the accompanying artery. Okay, you can see that here also. So here we have an artery, and here we have a vein. And again, you can see the lumen is bigger, the walls are thinner. Here we have a picture of the skeletal muscle pump. So you can see the skeletal muscles are squeezing, forcing blood up. Okay, you can also see here blood that has been trapped by a valve. So now this blood's going up, it's going through this valve, then it'll get trapped above that valve. So it'll keep moving up the valves until it gets all the way to the heart. The heart will pump it, and then it'll have momentum to get through all the arteries. So varicose veins is what happens in superficial veins. So veins close to the skin. So here we have our vein. On one side of the vein is skin. So the yellow is skin. On the other side of the vein is the skeletal muscle pump. So you're only pumping blood on one side. But our skin has lots of elastic fibers in it. Those elastic fibers are going to give the squeeze on the other side. So rather than having a skeletal muscle pump on either side, you'll have a pump on one side, elastic fibers on the other side. They will squeeze, forcing blood up through the vein. But we've already seen multiple times in this class what happens to elastic fibers as you age. They weaken and eventually disappear. Then you're not going to have as strong of a pump for your veins. So let's see what happens. So here we have a vein, a valve. Blood is trapped above that valve. It's not being squeezed, it's not being pumped through the vessels because the elastic fibers are too weak. So eventually you'll get so much blood pooled there that your blood vessel will bulge out. Right? We just have so much blood here that the vein stretches out. Eventually, the blood will get so heavy that it will just break that valve. Okay, the weight of the blood will be so much that the valve will prolapse. So here, my valve prolapsed. Now, all the blood gets stuck at the next valve. The same thing happens again. It gets really, really heavy. Oops. And it leads to stretching, bulging of the vein. Then that valve will prolapse. So now we have two bulges. And blood's at the next valve. And that will keep happening over and over and over again. So varicose veins are malformed, like malfigured veins due to the weight of the blood on the valves. So the elastic fibers weaken, the blood rests on the valves, leading to the veins to get deformed. Varicose veins aren't really dangerous, they're just painful and unsightly. The main way to treat them is to wear compression socks. So you start wearing socks that give the same pressure as the elastic fibers used to. Right? So you're wearing socks that compress the same way elastic fibers would have. So, deep vein thrombosis. Thrombosis is a blood clot. So anytime you see the word thrombosis, that means blood clot. A deep vein thrombosis is a blood clot that happens in a deep vein. Okay? Now what will happen is that blood won't be able to get past the clot and it will pool below it. So in this example, blood will get pooled below this spot of the leg. That leads to swelling and inflammation. You get lots and lots of blood in that area. The blood will start leaking plasma, and that will lead to swelling, inflammation, and pain. Okay, if it's somewhere like your leg, it can be treated. So they'll give you blood thinners. They can go in and remove the clot. It's not too dangerous. What's dangerous is when a piece of that clot breaks off. So here you have a deep vein thrombosis. So you have a blood clot forming. Sometimes a piece of that clot will break off, and that's called an embolus. So an embolus is a piece of a thrombosis that has broken off. It'll travel around the body, and eventually it'll get stuck in a smaller vessel. Remember that veins are big. Eventually, this embolus will get down to those tiny, tiny arterioles and capillaries and block them. That's called an embolism. So an embolism is when a blood clot gets stuck in a when an embolus gets stuck in a smaller artery and clogs it. Most commonly, we see pulmonary embolisms. A pulmonary embolism is when that embolus gets stuck in the lungs, preventing the blood from getting oxygen. And pulmonary embolisms are often fatal. Pulmonary embolism is sometimes called coach class syndrome. Coach class, like if you're flying, because people fly these long distances. Let's say you take a 14-hour flight. You're not moving around, so your blood is staying in one place. You're not using your skeletal muscle pumps to move it around. That blood will naturally start to clot. If blood pools in one area for too long, it'll naturally clot. Then you stand up at the end of your flight, an embolus breaks off, it travels to the lungs. So not all pulmonary embolisms are in airplanes, but a lot of them you see after long flights. So let's look at how blood clotting works. So here is my blood vessel. Okay, so that's all of the layers. Now sometimes the blood vessel breaks. Okay, so let's say you cut your hand, you cut a blood vessel, it's bleeding. Okay, or something like smoking. Smoking can destroy blood vessels. So you got a break in the blood vessel. Well, there are a couple things in your blood that will help. First, you have platelets. So we talked about those when we talked about the cells of the blood. Platelets are going to help clot. You also have clotting factors. And clotting factors are proteins dissolved in the blood. So when platelets and clotting factors come together, they're going to form fibers. So platelets are individually in the blood. Clotting factors are individually in the blood. They come together to form fibers. Then erythrocytes will get trapped in that meshwork, and that forms a clot. So a clot is made of platelets, clotting factors, and erythrocytes, and they plug up the hole in a blood vessel. That blood vessel will start to fix itself, and then eventually macrophages will come in to dissolve the clot. Okay, so macrophages aren't part of the blood clot, but they're responsible for getting rid of it once you fix the problem. So once the walls of the blood vessel reform, the macrophage will come back in and clear out the clot.